Hi everyone, welcome to Lab 3. In this section of the lab, you will need to implement various methods for IntDList. So in this video, I'm going to quickly go over what an IntDList look like and what the expected behavior of various methods should be like. So before diving into what an IntDList is, I want to give a quick review of linked list, which is a data structure that some of y'all might have seen from previous programming classes. So a linked list is essentially a data structure that consists of individual links that links together many elements. And every single element in this linked list has two fields. One is called the head, which holds a value. In this case, it holds an integer. And the tail is a pointer to the next element in the linked list. So this is what a linked list usually refer to that you might have known so far. And what we call it is usually a singly linked list because there's that only one link between every single element in the linked list. So in this example, you can see that we have a linked list with elements 4, 1, and 8. And usually when we draw diagrams, it looks like the following. So when we draw in this diagram, there's one link in between every element. And for an IntDList, which is a doubly linked list, it's essentially kind of an upgrade from the singly linked list in the sense that there are two links between every single element. It's linked in two ways. That's why we call it doubly linked list. Okay. So let's dive into what a doubly linked list looks like. A doubly linked list, to define it, is essentially a data structure that consists of elements with three fields. So previously, for singly linked lists, in the review, we saw that every element has two fields, a head and a tail. But in this case, we have another field that stores a link to the elements in front of you. So in this example, we have three fields. The first one is called the value, which it stores the value of the integer that we store at that element. And the second one, the second field is called pref, which I can highlight here. This essentially stores a pointer to the previous element in the doubly linked list. So if we look at an example here, the previous element of 1 is 4. So the pref points to the element that has the value 4. And next is the same the same kind of definition as tail in the previous example for singly linked list. Next essentially stores a pointer to the next element in the doubly linked list. Okay, so in this case, if we see it, next is a pointer to this element that stores 8, as 8 is the next element in the doubly linked list after 1. Okay, so hopefully this clarifies what a doubly linked list is. And when we draw a shorthand version of how this will look like in diagram, we would draw kind of three boxes for every single element. The first box is the pref, and the second is the value, and the next one is the next field. Okay, this is what a doubly linked list look like. And for the following slides, I'm going to use this shorthand notation to kind of illustrate what a doubly linked list looks like and what happens when we perform certain operations on the doubly linked list, because this is easier to understand. Cool. So I just quickly introduced what a doubly linked list look like. Now I want to look at the doubly linked list that we provide in the Lab3 code skeleton code. So in Lab3, we define every single element in the doubly linked list as of type dnode. And in the dnode class, which you can check it out in the IntDList.java file, a dnode has three fields, as I just mentioned in the previous part. The first field is the pref field, which is a pointer to the previous element in the doubly linked list. And the value field is of type integer, and it stores the value that the element holds. And the next field stored a reference and a pointer to the next element in the doubly linked list. So let me quickly write it down. P node, the previous element and the next element are all of type dnode, and val is of type integer. Okay, so this is what a dnode is, and a doubly linked list is essentially a chain of dnode linked together. And something else I want to introduce is that we introduce a wrapper class that wraps around the doubly linked list that consists of a series of links and dnodes. And this wrapper class is called IntDList. So there are two important fields in the IntDList class. The first one is called front, which always points to the front of the doubly linked list, the first element. So in this example, it points to dnode that has value 4. And the second important field in this class is called back, which always points to the last element in this doubly linked list. Okay, so in this example, it points to the element with value 8. So one important thing to keep in mind when you're coding out the different methods for the IntDList for Lab3 is that you need to always maintain the fact, or in rigorous terminology, we call invariant, which means that this fact does not change throughout the whole execution of your code. You have to make sure that front always point to the first element in the doubly linked list, and back always points to the last element in the doubly linked list. So when you're implementing the methods, make sure to keep in mind to check that after, whether your implementation make sure you update the front variable to the first element when needed, whether you update the back variable to point to the last element in the doubly linked list whenever it's needed. Make sure to keep an eye out for these two fields and make sure when you need to update them, you do so in your implementation. Okay, cool. And in shorthand notation, in this slide, I will draw the doubly linked list in this format. Essentially, this is the front pointer, and the other one is the back pointer, and front always points to the first element, back always points to the last element of the doubly linked list.